Alright, this is how to solve the testing of differences between two variances. So the question says, an experiment compared 7 and 9-year-olds to solve a problem with abstract reasoning. 5 of the 21 7-year-olds and 14 of the 16 9-year-olds solved the problem. Is there any significant difference in proportion of children that can solve these problems based on age? And alpha equals 0.05. So to start off, our hoe will be 7-year-olds are equal to 9-year-olds, and the ha will be 7-year-olds are not equal to 9-year-olds. So first off, we'll take our area. See if I can get this in the camera. So we'll take our 0.05 and divide that by 2, which equals 0.025. And then mean equals 0 and equals 1. And let's see. So we need to find the critical value of these. See if I can make that thing right. And this is, just type it in the calculator. So our coefficient will be negative 1.96. And so we got to draw the graph. So here's where negative 1.96 is. Shade that. And then 1.96 will be about right here. So for the hoe to be correct, the critical value has to land within the white area between these two shaded areas. So it has to be between negative 1.96 and 1.96. And if it doesn't, then you reject. So here's what you do next. You do F6 to number 2, which is proportion z-test. Let's see, you gotta go back to, oh, come on. And it's actually number 6, which is 2 prop z-test, F6, yeah, number 6. And then you have to put in successes of x1, so that's how many 7-year-olds got it right, and that is 5 of the 21 of the 7-year-olds got it right, so put in 5 for successes, x1, and then for the number of how many 7-year-olds tried it, there were 21, so put that for n1, and then successes for number 2, which is how many 9-year-olds got it right, which is 14 of the 16, so the number for them is 16 is n2, and then it has to be not equal to. So it'll end up looking like, where the hell's the camera on this thing? Oh, so it'll end up looking like that. Alright, then we'll punch that in and see what it gives us. So here's our test statistics. We'll write it out, so it'll make it a little simpler. So x1 equals 5, n1 equals 21, x2 equals 14, and n2 equals 16. And let's see. So our p-value, p hat 1, p hat 2, and just our p hat. These are the ratios, so it'll be 19 to 37. So 19 got it right, and 37 out of 37. And then P2 is out of the 9-year-olds. So 14 got it right out of 16, which is, God, I'm losing my voice, 0.875. And 5 out of the 21 7-year-olds got it right, which is 0.23. And then our z value will be, it's probably going to be negative something. It's going to be negative 3.84, and that's our test statistic. And then this will be the test statistic that goes into the graph here. And so that will be, oh, hope you can see all that. That will land pretty far behind our coefficient, which is negative 1.96. And so 7-year-olds are not equal to 9-year-olds. So we reject the hoe and we accept the haw. So reject. And that is how you find testing the differences between two variances. So obviously 2 variances were the ages and how many got it right versus how many got it wrong. And there you go.